Okay, so here we are on to section 5.5, and what for most people is like the last section of the tricky identities. There may be a few more scattered about, but these are the last that most people try to memorize and use a lot in calculus. So these are called the double angle and the half angle identities. And once again, I like to start with, why do we need these? Why are we learning these? Well, it's kind of like sum and difference identities in the respect that if I wanted to double an angle, like let's say I said, hey, I want you to take 2 times some random x, okay, and the x is just a random angle. It doesn't work like you think it would. Like, I think a lot of people imagine that, oh, this 2, maybe I just need to take the sine of the angle x and then double it. Maybe that's how it works, but no, that is not how it works. And so just to kind of prove it to you, what if I took sine of 60, okay, and I thought about the sine of 60 as being the sine as 2 times some other angle. Now, what would the x be if I'm trying to make it a 60? Well, it would just be a 30. So if you sort of think of the sine of 60 as this instead, you've just thought about it as being a double angle. Okay, I'm doubling 30. And if you wanted to see if it was equal to just 2 times the sine of 30, like up here, you could do that, but what you're going to find out is that, we know that the sine of, if we just leave it like this, the sine of 60 is root 3 over 2. But if I did this, I'd be doing 2 times the sine of 30, which is 1/2. So does the square root of 3 over 2 equal 1? Well, no, it doesn't. So you have to be really careful with this too and get it out of your head that you can just double the whole answer. That's not how this works. So that's why these exist. Once again, they're going to look bad. And actually the double angles don't look too bad. It's the half angles that are pretty bad. I'm going to give you a minute to copy these. Then we're going to talk about why they look this way. And then we're going to talk about how to use them. So go ahead and hit pause and get busy copying. You can use theta if you want, like I did. If your teacher used alpha, beta, u, v, x, y, I don't know what letter they're using, but use whatever you like. And once you copy them, we'll talk about them. Okay, so if you're back, it means you are copied and you're staring at these with your mouth gaping open. Okay, they're not that horrible, and in fact, these over here are easily derived. Like if you're like, ooh, I want to see why they are what they are, you can easily derive them by taking sine of 2 theta and thinking of a double angle as just adding theta twice, right? Like for instance, the sine of 2 theta is equal to just the sine of theta plus theta. So hopefully you see that those are the same. 2 times theta is the same as theta plus theta. And if you want, you could then turn this into a sum and difference identity like you just did before in the last section. And when you do this, sine, cosine plus cosine, sine, what you're going to see is that I have the same thing added to itself, and therefore there are 2 of those. And so you could do that with every single one of these. I'm not going to because I'm already bored of it, but feel free to go through and prove to yourself. Half angles, I don't even know. I don't think I could prove these to myself unless I sat down for about a half day with a large cup of coffee, and then maybe I'd figure it out, but I don't know. These are what they are though, and they have been for a very long time. So let's work on how to use them and not necessarily how to prove their existence, okay? So how do we use them? Well, like we had above, what if I want you to prove, let me get a different color here. What if somebody says, find cosine of 15 using a double angle? Like they're forcing you into a specific identity. We did this in the last section. You probably already know the answer. You might still remember it. So we could do it with sum and difference, but they want us to use a double angle. So when it's something like this, That would be actually very mean. I don't want to use a double angle for that. I could use a half angle for that. Let me change that to the word half angle. There we go. That makes more sense. Okay. If they want us to use a half angle for this, then what you're trying to do is you're trying to compare cosine of 15 to what you see here, which is the cosine of something over 2. Well, what would that something have to be so that when you divided it by 2, you got 15? Well, hopefully you see that that would just be 30. Right? So it's a rewriting experience. You take what they give you, you rewrite it using the identity they want you to use, then you figure out what that angle is, and now we can plug it into this side. Okay? Now you might be thrown because when you copied this down, I had you write a plus or minus, and for now I'm still going to write the plus or minus, and we'll talk about that at the end of the problem. But let's copy what it says. It says 1 plus the cosine of the angle. Now the angle that I had to do was 30 to make this work, all over 2. So let's just work on simplifying, and then we'll figure out what the plus or minus junk is. Okay, well, I have a big square root. 1 plus, what's the cosine of 30? Root 3 over 2, and then on the bottom I have a 2, right? Okay, so what we would do from here is try to simplify this fraction a little bit, and what that means for me is that on the top I'm going to put these together. So I'm going to call this 2 over 2 plus root 3 over 2 all over 2. Hopefully that makes sense. I'm just getting a common denominator right here of 2 over 2, just so I can add these together. And the benefit of that, guys and gals, I lost my plus or minus. Don't tell anybody. Okay, the benefit of that is because now whenever I add these together, this is going to be a lot easier to clean up, right? Here's my fraction on the top. Here's my term on the bottom, and when you simplify this, guys, these two denominators are just going to come together. So if you don't see it, think of this as 2 over 1, and then do the whole flip the second and multiply thing. And when you flip the second and multiply, it's going to become a 4 down there. And what you can do from here is actually split up this radical and do part of it on the top and then part of it on the bottom. Now, what's the benefit of doing that split up? Well, you know the square root of 4, right? The square root of 4 is just 2. So that's what it's going to turn into. Now, let's decide on this whole plus or minus thing. The reason the plus or minus is there is because you need to check which quadrant you're in and which function you're doing and decide if the answer should be positive or negative. I mean, let's think about it. 15 degrees is what we are trying to find, right? Where's 15 degrees? Well, it's somewhere right here. In this quadrant, is the cosine positive or negative? Well, it's positive. So when I do my final answer, it's just going to be positive, okay? But if it had been an angle in another quadrant, that's whenever you would need to do the negative on the outside, like if it was here or here. Okay, cool. So that's how you would use half angle. So hopefully that doesn't hurt your head too much. Let's look at another example of how you might be using these. Okay, let me do one that maybe has a double angle. Actually, I'm just going to do a fun one that does all kinds of stuff. Okay, so let's pretend that, let me stick a little theta right here, and let's do a triangle. Let's do another 3, 4, 5 just to keep it easy for now, okay? And let's pretend that you were asked to find several things. Let's pretend that somebody said, okay, find the cosine of theta, find the cosine of 2 theta. Maybe they want us to find the sine of theta over 2. Okay, something like that. Okay, so what we are going to do is use our identities to solve these. Now, for cosine of theta, you shouldn't need a lot, right? Because cosine, you should know, is just the opposite. Nope, it's not. It's the adjacent over the hypotenuse. So adjacent is 4, hypotenuse is 5. Done. Like, that's it. It's an old question, right? Kicking back to the whole SOHCAHTOA thing. Now, if I want the cosine of 2 theta, please don't just double this answer. It is not 8 over 5, okay? You're going to have to use an identity from above. So cosine of 2 theta, let's go find it. All right, I have 3 choices. Which one should you choose? Use whatever your heart desires. I mean, honestly, I think I'm going to use the middle one on this problem, and here's why. I in part A I already found cosine, so let me choose the one of these 3 that only involves cosine. But honestly, you could use whatever you want. So that said 2 cosine squared theta minus 1. Okay, so what I'm going to do to solve that is, well, I know that the cosine of theta is 4/5, right? So I'm going to erase cosine of theta and put in the 4/5. And I still need to leave that squared on it though, so be careful with that squared. And now I just do math. Now I just solve it. So let me do my math out here to the side. You're going to have to do PEMDAS, people. So make sure you square that first. Then we're going to multiply by 2. Then I'm going to get a common denominator and solve. So I'm getting 7 over 25. Fun with fractions. For some of you, that'll be the hardest part of this. It's just making sure that you don't derp up your fractions when you're doing your simplifying. Okay, and then the last one is sine of theta over 2. So for this one, I once again need to look back at my identities. And if you were to scroll back up to the top, you would see that the sine one is plus or minus the square root of 1 minus cosine of theta over 2. Now cosine of theta we already found, it's 4/5, so I'm just going to stick it there. And then we're just going to simplify this. So right off the bat, 1 minus 4/5 is 1/5. So what is 1/5 over 2? I'm getting 1/10. And if you want to call that root 10 over 10, you can. Now I'm going to go ahead and leave it as a positive. How do I know it's a positive? Well, look at all, this is just a picture of a triangle and all the sides are positive, so this is going to be a positive answer also. Alright, cool. So there's just another fun way that you can use double angle and half angle. And like I said, hopefully that gives you enough to be able to solve some problems and try a little bit of work. But if you get stuck and you have a request, send me some problems and I'll work them out on video for you to show you how it's supposed to work. But have fun with these and good luck. Thanks.